Hi, and welcome to this video on the GeMRTOS system architecture. In this video, the GeMRTOS system architecture is described for its NEOS 2 version using Intel FPGA devices. GeMRTOS is a generic, embedded, multiprocessor, real-time, event-driven operating system. All of these features are based on a multiprocessor hardware architecture. This architecture is made up of one or more processors. Each processor has an identification number, but there is no hierarchy among them. The system architecture relies on the GeMRTOS controller. It manages the system processors through hardware interrupts. The system processors are only interrupted by requests generated by the GeMRTOS controller. A memory-mapped system bus is used by system processors to access instructions and data. The system memory stores the GeMRTOS code and data structures, as well as the application's code and data. The GeMRTOS controller's control and status registers are also mapped into the system bus's memory map. In this manner, the processor can access the GeMRTOS controller's functionality by simply addressing its register in the system bus's memory map. One of these functionalities is the mutex register, which is required to access a critical section of the GeMRTOS code. The system bus is also used to access the input and output devices. All of these input and output devices are also mapped into the system bus's memory map. UARTs are used in the system architecture as standard input and output, as well as standard error consoles and individual terminals assigned to each processor. The GeMRTOS controller handles all interrupt requests from UARTs as well as from input and output devices. As a result, the GeMRTOS controller is in charge of determining which processor is best suited to execute the interrupt service routine during runtime. The GeMRTOS controller handles all external hardware events and is configured during runtime to determine which processor should be interrupted in order to execute the GeMRTOS code based on the status of the GeMRTOS data structure. The system architecture can support both homogeneous and heterogeneous multiprocessor systems. The first version of GeMRTOS was written as a composed component for the Platform Designer tool, and it was based on Intel's NEOS 2 processor. It is compatible with both the economy and full versions of the NEOS 2 processor. The Intel memory-mapped Avalon bus was adopted as the system bus for the NEOS 2 version of the GeMRTOS. As a debugging facility, the composed component incorporates an Avalon monitor that traces all the processor bus activity. The Avalon monitor has a FIFO memory that can store bus activity for later analysis. The GeMRTOS controller defines Avalon ports for each of the system processors. These ports are defined to turn the processor into a wait state when it either has to wait to be granted the mutex or when no task requires execution, and thus the processor is turned into an idle state. This mechanism allows the system's power consumption and system bus utilization to be reduced. As a result, if no tasks require execution, all processors remain idle until the next event. All internal components of the GeMRTOS system architecture have an input clock. Consequently, this input clock defines the clock domain of the internal components of the GeMRTOS system architecture. To improve system performance, an external clock is defined for the external components. Avalon bridges are the interfaces that connect the clock domains. A JTAG Avalon master is included in the GeMRTOS component for debugging purposes. Using Intel's System Console tool, this JTAG component allows reading and writing to all device registers connected to the memory-mapped Avalon bus. A hard processor system interface with a dedicated memory-mapped Avalon bridge is included for more advanced debugging support. For more efficient debugging techniques, FPGA devices with hard processor systems, such as the Cyclone 5 family, may be used. The Intel Platform Designer efficiently implements this multiprocessor system architecture as a composed component. The GeMRTOS system architecture component enables the connection of different input clocks for the processor and the external bus, as well as the use of the same clock signal for both input clocks. In the GeMRTOS component, the number of processors in the system architecture can be easily parameterized. The economy as well as the full NeoS 2 version can be chosen for inclusion in the system architecture. The GeMRTOS open source project allows including more parameters to make the system architecture flexible and adaptable. For each processor that must be connected to the system memory, the GeMRTOS component provides one external memory-mapped Avalon port. Implementing a multi-processor system architecture is thus as simple as installing the GeMRTOS component in the Platform Designer development tool. GeMRTOS is a game-changing innovation for embedded real-time systems. The Intel NeoS 2 processor was used in its implementation, but the source code is available for porting to other processor architectures. Information is available on GitHub and the GeMRTOS website. Please contact us at GeMRTOS.com for more information or if you want to join us in contributing to the project. Thank you for your time.